Hi everyone, welcome to the demonstration of GraphMind. This is a tool to develop. This tool helps you to build from spec to code, given a change from spec to the code change from end to end across multiple microservices, multiple repositories, and other resources associated with the entire system. So the objective is basically we have for any production system or any a well-matured system, we'll always have multiple microservices interacting with other resources like databases, cloud resources, etc. And current code generation tools available in market, they operate more locally in a workspace basically, and they work based on the prefix and suffix of the code on embeddings, and they usually lack the visibility of the system end to end at the higher level. So I developed this as part of hackathon at Cred, and let's see how it works. So I built a temporal workflow. It takes multiple repositories. Here we are taking these repositories, which are like fairly imitate production system. Here this is a social service basically, where we have an authentication service, where we have a social service which is much like a Twitter or any social feed, localization service for translations, and then we have a notification service for push notifications when a post is created or when a user follows someone. So this set of repos fairly imitate any production system. So we're going to take these repositories. Let me just build the request. And we have this common folder. So these are the repositories we're going to take for the construction of semantic graph, and we're going to give a path where we will dump all the graphs and the final graph. Okay, this looks pretty much. Yes, let's start the workflow. So the workflow starts, and you see it initiates child workflow for each repo. It follows basically the steps where it first downloads the repo and then builds AST. So when building AST here, this is specifically built for Golang and gRPC. So it starts by identifying the entry points for each API, and for each API builds a separate AST end to end, dumps in a separate file for each service to capture the control flow. Once this is done, it then goes after downloading the repo. It generates a repo level metadata, which is basically using the build files like go.mod or build or Gradle, etc. And then it builds the AST control flow, from the entry point till the end of the API. Now these AST flow control points, these ASTs are given to Claude for annotating semantically. So say like we have a method where there is HTTP client call. So the AST will capture a method for HTTP client call, but which is not that useful. We need to know what is the target service that is being called for for code generation, for doing anything meaningful. So using Claude, we can give pass this AST with the entire control flow. It uses the variable names and even the URL in the target API, and it infers the target microservice, etc. So it gives a semantic annotation, semantic metadata to the graph. Now, once that is done, the entire AST final RDF graph is built. So now we see the workflow has finished, and for all of the repos, the graph has been generated. Okay, now we have the final graph here in the all graphs to combine graph RDF. We can even visualize this graph. We have a very nice service. So this is basically a RDF graph. Right. So if we just open this folder, we can see all the graphs. So these are completely text-based, open schema, RDF-based, and LLMs understand RDF. So this is a combined graph from all of the graphs for each API entry points. Okay, now we can even visualize this combined graph here. We'll just paste the graph content here, and use post and visualize. So we see this RDF graph for building the graph for the RDF we just got generated. It's taking a while to generate the entire graph. We'll see once it's generated. Now we'll use this. I'll use this graph. Use this graph. Or we can simply pick up the out from the output basically here instead of working so hard. And just copy this and paste it in the UI. And I just give some a small change where we want to add an alternate image in the sign up process. Also in the social feed below each post, we want to display a post from Android or iPhone. Okay, and then we say analyze spec. So while the LM is building the code chains, we can see the graph. Yes, yeah. So we can see how detailed the graph is. So we have the Arco repo. This of course is located in this repo. Okay, let's zoom in. Oh, let's sorry, man. Yeah. So let's forget this messaging service. I guess like the outermost area. Yeah, here we can see the start changes. We have two different repositories where we have to make change. For post from Android or iPhone, we have to make change in the feed post service. Update the post creation, we have to capture the device. So it basically gives a very brief summary where all we have to make changes. Now this can be further developed into more structured output, and it can fit into Copilot kind of code generation tool, where it can locally generate the changes for all of the repos. I guess yeah, the graph generation is complete. We can just visualize the graph a bit. So yeah, we can have like login service. It uses like has environment variables like verification. It uses database profile. It also lists the database being used, the endpoints. Okay, so we have profile master service. So yeah, we have basically a lot of information which is used by LLM to generate end-to-end code. Thank you.